By bringing developers and security together, you don't have to choose between speed and security. Develop fast, stay secure.
Hello, welcome to another episode of Cloud Security Podcast. Today, we are starting a new month with Kubernetes security, and the topic today is Kubernetes best practices. Let me just bring the damn thing up. Oh, there you go. There it is. But for this, we have a past guest come on, Jimmy Mesta, and I'm going to play the music in, and let's get into it straight away. Hey, I just want to wait for the tune still.
Yeah.
I guess it's still definitely worthwhile to get the hype going, man.
You gotta get the hype up. Yeah, that's right.
How are you going?
Yeah. It's going well. I have my afternoon coffee. The kids are asleep, napping. Life is good.
Life is good. I've got my little cup of coffee as well, man.
Nice.
Got a few people coming online as well. Cool. Morning, Vinny. Thanks for coming in. And for all people joining in, feel free to drop your questions in. But we're talking about Kubernetes best security practices. So, man, to start off with, for the one or two people who don't know you in the crowd, can you give us a brief intro on who you are and where you are today?
Sure. Yeah. Thanks again for having me. I feel like Kubernetes security is the gift that keeps on giving. My name's Jimmy, and I am the CTO and co-founder of a software security platform called KSOC. My journey started about 15 years ago, though. I inherited a kind of disentangled WAF program at a very large enterprise right out of college, and kind of got into AppSec. And I actually have a degree in security that was sponsored by our friends at the NSA, which was an interesting story. But I kind of bounced around between offensive pen testing style roles and defensive, I guess, in leading compliance and security teams at various companies. But about 6 years plus ago, I took a nosedive down in the rabbit hole of Kubernetes. At 0.8, the company I was at, we adopted it. We rolled our own Kubernetes using KOps and Chef and all sorts of hairy things, pre-RBAC, pre-anything. And I just kind of got very into the space, what it was doing to the software development lifecycle, and ultimately kept building on that skill set and build a company out of it. So here we are today.
Wow, man. I think very interesting to kind of go into the space as well from an offensive side as well. And worthwhile calling out, I don't know how many people out there understand Kubernetes as well. They kind of hear the word, and because it's a word that translates onto something else as well. From a technology perspective, what is Kubernetes for people who, just explaining Kubernetes is like a thing. So how would you explain Kubernetes to people who are in the tech space?
Yeah, so Kubernetes as a household word has taken quite a few meanings, and it started as a container orchestration platform. If you go to kubernetes.io, that's what you'll see. I think what we could talk about today is like the nuance behind that. So to think about what a container is, right, which is really a software packaging mechanism that shares, the host's kernel, and it really lets developers build and ship software in a very kind of modular approach, repeatable fashion. And Kubernetes was built to give you several APIs and guarantees around deploying, orchestrating, and managing multiple containers inside of a compute platform. And it's like a data center inside of your data center, right? It does networking, it does secrets management, it does kernel level stuff. It has its own access control and authorization layers. It's very much, a complex set of APIs that you ultimately run software on, and it does a lot.
And I think that the data center within a data center is what makes people get scared of it. It's like, holy shit, there's another data center inside a data center. And you touched on containers as well, because another question that I get quite often is the whole Kubernetes and container? What's the difference?
Yeah. So, I mean, a container is like the atomic deployable unit of, your application representation inside of Kubernetes. You don't need Kubernetes to run containers. There are other ways to make a container, the process start and serve traffic and do networking and things of that nature. Like you can just do Docker run and just open a port and serve your application that way. But the reason we have Kubernetes is really those strong guarantees, right? It's saying I want X, n number of replicas. I want this pod to talk to this pod. I want environment variables to always be present in this running container. It gives you the utilities you need to run containers at scale. I mean, even a small scale, doing Docker run doesn't really work. So, for local development and things like that, using a single container or even Docker Compose, things like that, where you're kind of, merging multiple containers into one system, that's great. But Kubernetes is when you need to run it in production.
Right. And the other one, which is another popular question for us, is the whole Docker spaces, because especially after the news came out that Kubernetes is stopping support for Docker, and be like, oh wait, so it's different. So what is the relationship between Kubernetes and Docker there?
Yeah, so Docker is a company, right? To start with, right? It's in people. I think that's easy to forget that like there's actually like a for-profit venture-backed company. Now there are open source projects that Docker kind of consists of, and Docker kind of led the container renaissance, right? Like it gave developers this very clean CLI that stitched together a lot of underlying kernel technologies and abstracted away the need to understand how to like create a container the hard way or from scratch and just let you run containers. And its relationship to Kubernetes really is it's in Kubernetes runs, this component on every node called the kubelet, and the kubelet takes requests from the API, and ultimately you have a container runtime interface that does something like a Docker run, right? So it's not that we've abandoned Docker in general. We've established other patterns, right? Like CRI-O and Containerd. Docker is pretty monolithic as a utility to orchestrate containers and create containers, when really you need to pull an image from a registry, unpack it, and run it ultimately using what we call run C to actually run the container process. And we have eliminated the need for all of the things that we, the entire Docker daemon and Docker ecosystem provides. But it's not as scary as it sounds. You won't even notice it, right? Like you use Kubernetes, you're not really dealing with it at that level. So it sounded scarier than it was, I guess.
Yeah, I mean, the simplest way to, at least the way I explain to people, is like the same as Google Chrome on your MacBook or wherever. If for whatever reason Apple decides to stop supporting Google Chrome, doesn't really mean you can't use a browser anymore. You just use a different browser. And
sure. Yeah.
That's like the simplest explanation I could come up with. But yeah, it's not like your thing is gone. I was like,
no. And your Docker file and your image and all the things that you're used to doing stay the same.
Yeah, pretty much.
The plumbing changed.
That's right.
Yeah.
The other question that I also get is, because you kind of said this in the beginning when your first 0.8 that you were working on, using Chef and other things to kind of create Kubernetes, which I imagine was the bare metal Kubernetes. Mm-hmm. Is that still a thing? Like, and what is it? I guess for people who don't even know what that is.
Yeah. If you rewind in the early days of kind of Kubernetes as an open source project, we didn't have managed Kubernetes. Like AWS and the big cloud providers didn't have these very slick, easy to use managed environments. So you built your own clusters, right? Kubernetes the hard way, as our friend Kelsey Hightower would put it. And that meant you needed to stand up nodes. You needed to place different components on those nodes, certificate authorities, the kubelet, like the container runtime, like you had to deal with networking those nodes together. So we use Chef to do some of that. I mean, you could argue that wasn't the best mechanism, but Kubernetes, to your question, like on bare metal, exists in a big way today, and bigger than you would think. I think there's still a lot of large organizations choosing to go into building their own clusters. Maybe it's not quite as large as the managed space, but there's a lot of big companies that are all in on running their own Kubernetes. We have the tools available too, like KOps, KubeADM, and there's Terraform modules. There's great bootstrappers out there that you can run your own Kubernetes. Now, you better have the expertise to deal with that. I guess that's all that needs to be said, right? There's more to it than running managed Kubernetes if you're doing it yourself.
Yeah, to what you said, it's a data center inside a data center. You're technically having a team skill set where you can run an entire data center, for lack of a better word, which is based off Kubernetes.
Pretty much, yeah. And the security, like now our lovely shared security model that the cloud provides is gone. Now you own every single flag that the API server consumes. You own the security of the kubelet. You own all the different things, networking, that maybe you offloaded some of that to AWS or something in the past. You don't get to do that anymore when you build your own.
Yeah, wow. And for context for people, what is a managed Kubernetes as well? So we should probably clarify that, because I think most of us would know it, but some people who may be listening to the first time may not know what it is.
Yeah. It's pick your major cloud provider. The big three all have what they call managed Kubernetes, and essentially it is kind of two things. One, under the hood, the Kubernetes API. If you were to run your own cluster in your own data center, you are responsible for that instance or multiple like VMs that manage the API server and the control plane. Managed Kubernetes, you don't have that ability. Your cloud provider is responsible for that. They give you the API. They give you some configuration. Yeah, there's switches and toggles that you can change as you bring your cluster up, but you don't have access to etcd. Really, you don't have access to a lot of the underlying control plane components, which is probably great for 99.9% of organizations, right? Like, to be honest, and that's that mixed with easy, well, depending on the cloud, easy to spin up clusters, right? They're part of node pools that give you container optimized like operating systems under the hood. The networking's kind of laid out for you. You have a path to expose the Kubernetes API, and they have deep integrations, which is another key point. Like AWS IAM is kind of like baked in, Azure AD, like these things work well-ish with managed Kubernetes out of the box. When, again, you build your own, you're doing it like all by yourself. So like GKE inside of Google is a good example of like, they have tons of features that don't even exist in Kubernetes proper. Shielded nodes, workload identity, actually using the built-in KMS functionality of your cloud to encrypt secrets that then get persisted to etcd. Those things are very hard to do in your own DIY clusters, but managed makes it easy. So
there you go. So well, do you want the hard path, or do you want the that's one of those ones with the one that Hightower wrote? Do you want the hard path, or would you rather just like use a shared responsibility model and move on with your life?
I think most companies want the easy button. I mean, they should, right?
Yeah, I hope so. I'm going to quickly check into the comments that came in as well. So we've got a few more people who came online. Hey Rama, hey Belay. I was definitely surprised by the amount of use of unmanaged Kubernetes that's there. So this next question is from Vineet. What security plan you do to protect Kubernetes cluster nodes and pods? Any particular security baseline you recommend? And I think that's a great question. The caveat I'll add is, if you can probably talk more from a managed perspective as well. What's there?
Yeah. So the kind of expected answer here is like the benchmarks that exist, CIS, NSA, hardening guidelines. They offer a good start. I will not go into a vendor pitch of why you should talk to me about our product, but aside, there are lots of open source tools out there, and we're even seeing more things like RBAC Police from Palo Alto Networks, which is like specifically looking at some obscure RBAC configurations inside of the cluster. Kubebench is a classic CIS open source kind of CLI utility. There's in the world of managed Kubernetes, like each of them have their own CIS benchmarks, I believe. I know GKE has one, and EKS, I believe, has its own. I'm not positive on AKS at the moment, but your cloud provider should be able to test for some of that too, right? Like if you use Guard Duty or Azure Defender and things like that, they're going to surface CIS managed Kubernetes specific issues. And if you're rolling your own Kubernetes, there's like 50 more checks that you need to do. So I would say like also PCI has some stuff now, which is awesome.
Oh, wow.
PCI DSS has recommendations pertaining to container orchestrators, Kubernetes. So Rory McCune has written a few really great blog posts out there diving into each of those. So there's a variety of ways to get your baselines, and most folks start with CIS.
Yeah, sweet. I think hopefully that answers your question, Vineet. Great question, man. I've got a related question from Ameya, which is a naive question: OWASP top 10 and how they are related to Kubernetes. Or let me say, if I am using Kubernetes, then how can I remediate top 10 OWASP in my cluster? Because the follow-up also is that which one to follow? There are too many standards. So which is the hard reality of the world we live in.
That's the world we live in, correct?
Yeah. So what's your thoughts on the whole OWASP top 10 and Kubernetes?
Yeah, I mean, we could just get into it, I guess.
Actually, before we get into it, would you say the OWASP top 10, which is the web top 10, is there any relationship between that and the Kubernetes one? Because you know how people, when they look for OWASP top 10, they're going,
it's always it's always the web top 10. Yeah, it's no, there's really no. I mean, there's a relationship that it's a top 10 project within the OWASP Foundation, right? But that's about it. Like, there's no crossover.
But if it's an application running on Kubernetes, which is a web application, I guess, then you can use both, I guess.
Sure. I think you would totally. So the OWASP top 10, the application security top 10 has evolved a lot. It used to be very like cross-site scripting, SQL injection, like very much like this is a vulnerability and here's why it's a problem. Now we see things like insufficient logging or
broken authentication,
broken auth. And there's definitely crossover, right? Like I think the AppSec and infrastructure security are the Venn diagrams, like getting smaller and smaller. You can't really just, I don't feel like you can just do AppSec anymore. Like you can be a total expert, but it's like the exploit almost always has something to do with the underlying infrastructure. SSRF, right? Server-side request forgery. That is different in Kubernetes versus other systems. Remote code execution. Great. I found it in my web application. What am I going to do with it? Well, in Kubernetes, you can do some damage, right? So I think that there's a convergence for sure happening today of AppSec and infrastructure and cloud security. You kind of have to know everything, unfortunately. To be
becoming a full stack person over there now. It's like a full stack developer, full stack security person now. Knows cloud and application security as well.
That's how you make the big bucks, I guess.
Yeah, that's right. I think worthwhile before we jump now. Thanks for the question, Amaya. Before we kind of jump onto the I guess the OWASP top 10 for Kubernetes, which you've been part of, I also wanted to kind of talk about if there are things. So we're building a hypothetical environment, the data center within data center. Are there things within Kubernetes that could help build this thing? Or, I mean, I guess and maybe would you start with OWASP top 10? Is that where you would want people to start with when they're trying to build a Kubernetes cluster or port?
I think so. Kubernetes as a open source massive project offers the tools and built-in functionality to have a relatively hardened cluster, right? Like there's a lot of really good stuff that you don't need to go buy, build, adopt other things, right?
Right.
So, things that come to mind are the now deprecated pod security policies, which are, now pod security standards, the network policy API, the objects themselves. Like you don't need to use a service mesh. You don't need to use these things that, maybe are a little intimidating. There's also, even there's RBAC, right? Like RBAC is a security feature, but also when you do it incorrectly, it's its own vulnerability. So I think Kubernetes offers a lot out of the box. The problem is like a data center, right? Like you can build a government style data center that's super hardened and secure, or you can have the most open Swiss cheese looking infrastructure possible, like everything in between. So like Kubernetes is flexible, which means that you as the operator, you have to turn the knobs and the levers to get to a point where you're comfortable. And I think those knobs and levers are complicated, right? And so to answer your question, the OWASP top 10, for me to create it was like step one on your journey, right? Like what's happening here? Like how do I, instead of the fire hose of everything all at once, how do I understand what's going on in a cluster? What do I need to learn in depth to manage this thing and feel confident doing it? That's really the goal of the top 10. It's a guide book. It's a reference doc. It's not a prescription. It's to start your journey.
Right. Because to your point, then you can probably use the OWASP top 10 for Kubernetes along with, say, CIS benchmark or the PCI benchmarks or whatever other benchmarks are there as a way to also, if I'm, I don't know, starting today and I've been given a Kubernetes cluster, just one, not multiple, just one Kubernetes cluster. And
you're lucky if you just one. Yeah.
Yeah. I mean, even that, I imagine it's a big thing. But because it could scale. I think what people underestimate is how big even one cluster can scale. It's amazing, and I think if I was to go, so if I were to start today with just securing one cluster, if I have to, what Vinny said and what Amaya said, have a couple of security standards as okay, these are the baseline that gives me like, do this, do this, do this, do this. Then the OWASP top 10 for Kubernetes is like, oh, what should I be looking out for? Like the first one, which is the security misconfiguration.
Sure.
I mean, you can actually, because you have the cheat sheet as well, right? I think you helped write the cheat sheet for OWASP as well.
Yep. There's the OWASP itself, I think everyone assumes it's all AppSec all the time, but when you actually look at what OWASP as all the contributors, there's a ton of stuff out there that has really, not really AppSec. There's all sorts of top 10s. And when I first kind of published the Kubernetes top 10, there were definitely some people who were like, what? Like, there's only one. And it's like, you should probably look in 2022. There's probably 12 of them. And that's good. Like the world needs more educational reference material that we're all working on together. So it came out with, the cheat sheet is how to where to look, how to fix it, the details around, some of these problems. And the cheat sheet is, there are so many cheat sheets. If you go to just like cheatsheets.owasp.org, there's one for anything that you could imagine for the most part. So it's cool. Like there should be. There's a Docker one, there's a Kubernetes one, there's serverless, there's like all sorts of different things. Every web framework out there. So yeah, the top 10 it's good for things like we can discuss the top 10 in the span of a podcast or a screencast, and like you could, cover a lot of ground. And I think that's the point.
Yeah. And I think to your point, then I think for people who are looking at, because these are free resources as well by OWASP, they don't not like a paid wall or anything. And for people to be able to at least have access to a cheat sheet, a top 10 Kubernetes, and a few benchmarks, that's a good enough start for anyone. And to your point about what the world needs more of it, I think I've got a comment from Ankit over here as well. Interesting topic, definitely something industry needs more dedicated effort on. So thanks for sharing that as well, Ankit. But yeah, there's definitely a lot of need, I think. And for people in the cloud security space, there is an OWASP top 10 for cloud security project as well. So if you want to contribute and maybe make it a thing, I believe the project is still in draft, but to what Jimmy mentioned, there's a lot of projects there which probably needs a breath of fresh air at this point in time. So definitely check those out. And maybe we can use that as a good segue into switching to the OWASP top 10 API. Oh, sorry, top 10 Kubernetes.
There's one for APIs as well.
Yeah, that's right. So like there's one for API as well. So the first one, which is in that top 10 Kubernetes one, was security misconfiguration. I know we only have half an hour to kind of go through 10, so we're gonna try and squeeze as many as we can. But for security misconfiguration Kubernetes, what do you think people should know more about?
So Kubernetes as an orchestration platform is just one big collection of configurations. So it only really makes sense that it's the first one that can go wrong because everything is a configuration. The intention here was really to call out the flexibility of Kubernetes and what it gives you. So think about a container and how it can interact with the kernel. It can be privileged. It can have excessive system call capabilities that you don't need. There's file system configurations that, read, write, depending on how and what the container needs access to. There's what user is that container running as, and that all bubbles up into Kubernetes. So it makes number one because it's hard, right? Like it's just like there's so many combinations of things that you're bound to get something wrong, or that workload needs to run as privileged. How do you limit the blast radius? So the examples in the top 10 are just scratching the surface. But you will see, imagine you have a big cluster and some web applications running. You're bound to have a web app vulnerability. These misconfigurations are what happens next, right? I got a shell on this running container. What can I do? Well, if you look at the security context of that pod, it can tell you your path forward. If it's privileged, or if you have mounted the Docker socket into it, you're better off as an attacker. You're going to be able to traverse out of the context of that container. And that's what number one's all about.
And OPA kind of fits into this as well somewhere?
Yeah, so there's two steps. One is finding misconfigured workloads, defining what that is. CIS does a decent job of this. There's lots of best practices, that we can follow. But number one is like finding things that are running. There's also finding things in code. And then there's also blocking these things from happening again. Right. So all three of those steps are really important. Open Policy Agent and kind of the complementary project Gatekeeper offer the ability to, number one, audit your cluster, right? Like in an open source way. Our platform does this as well in other ways, but the premise here being like find misconfigurations, fix them, and block them from happening again. And we use admission controllers typically to do that. So the Kubernetes API has the ability to stop things like privileged workloads entering the cluster or a particular namespace. So it's almost like back to our firewall analogies, it's almost like an API. It's almost like a firewall to some degree, except it's not network traffic. It's configuration of Kubernetes objects.
Right. And to your point, then, because Kubernetes is a declarative language, or I mean, not language, I guess, a framework, if you're going to use that word, where you define what you want, it just creates it, manages it. So I think the simplest definition was that. So to your point, then something like an OPA gatekeeper or admission control, like these things help you manage more, sorry, not manage, but almost prevent more of these misconfigurations from happen as well.
That's correct. Pod security standards as well.
Right.
If you want to use the built-in Kubernetes way, they offer 3 different like risk tolerance baselines, and you can choose what you'd like to be more permissive or like fully locked down.
Yeah.
There's Kyverno. You can write policies in JavaScript. Like you can get as creative as you'd like. The key is actually doing it though, right? It doesn't necessarily matter what tool you pick. It doesn't have to be Open Policy Agent. There's a lot out there that can help you.
Yeah, I've been told one thing. I don't know if people know this, but OPA Gatekeeper is primarily on Rego, and everyone hates Rego. It's not the easiest language. That's why Kyverno is definitely getting a lot of popularity. We actually have someone talking about Kyverno later in the month as well, so that'll be interesting.
No, I mean, keep in mind OPA and Rego are Kyverno's Kubernetes specific. So if you're just doing Kubernetes policy, great. If you need to do other policy things, Rego's not everyone's favorite, but we use Rego a lot. It's fine. It works. It does what it needs. To me, it's still better than writing them in JavaScript, but that's just my opinion.
I think the example that I gave to someone who did a whole entire talk on the whole Rego thing was when you have to kind of say you're adjusting, you don't mind. It's almost like drinking poison. You're like, oh, well, I don't have any other choice, which is I'm going down that path. I'm just kidding, obviously, but I think I definitely find that the context of OPA is definitely beyond because a lot of people use it for multi-cloud as well. So there's that.
It goes well beyond Kubernetes, which is, I mean, it goes into service to service authorization. Like there's a lot of interesting projects built on OPA and Rego that have nothing really to do with Kubernetes configuration.
Right. Yeah. So maybe Kyverno for people who are just like primarily to what you were saying, for all those people who have unmanaged like massive clusters.
Sure. You just use pod security standards. Like start there. Like just understand what those are, what they do, and you don't have to learn any language.
Yeah, and maybe that's a good segue to the next one as well, which is there's a whole supply chain as well for what you use, which has been the topic of I don't know for how many years now, especially after the whole presidential order. Supply chain has become like a thing. So supply chain, what's that context in Kubernetes space? Supply chain vulnerabilities.
Yeah, I think it made the list because if it didn't, I'd get yelled at in 2022 if you don't talk about supply chain and S-bombs. Say S-bomb 3 times and you turn into a pumpkin or something. But it's in Kubernetes specifically, I think, and it trickles down into containers. It's you're running a ton of untrusted code, whether it's Kubernetes, the platform, right? And all the different pieces. Like think about Argo CD, think about Flux, think about Helm, think about like the way we bring in like blindly random stuff into the cluster just because it's there. We also build our software on top of base images that come from who knows where. Those base images might have packages that we don't use. Like it's such a mess of third-party stuff that it has to make the top 10. Kubernetes just makes it easier to run untrusted stuff. To me, we actually have ways to make that better. Again, like admission control, integrating that emission control with things like cosign, image integrity, writing policies that only allow images to come from certain places. We have great defensive mechanisms, and they're largely unused. So it's a big deal, right? And like building an image is hard. Building an image that doesn't have extraneous packages or vulnerable packages, it's a problem I see every day. So it makes sense that it's only kind of multiplies in the context of Kubernetes, in my mind.
Wow.
Yeah.
And to your point, then, is this where the whole, I know the whole SBOM thing is there, but things like what libraries your containers using that you're using to build your Kubernetes cluster, like those kind of things come into this as well?
Yeah, I mean, I think so, right? It's a good place to understand what's running. Like, I think as an industry, we're all still trying to figure out like what to do with this SBOM artifact at the end of the day. Like,
yeah,
I got an SBOM. I have the SBOM. I have lots of SBOMs. And that is going to evolve. I think it's going to evolve in a big way where auditors, incident response folks, like people are going to ask for SBOMs before they buy your product.
Yeah.
And that's already happening. So
it's already happening.
I mean, you've heard a few different, we all know the classic, like, vendor security questionnaire. We've all dealt with the vendor security questionnaire. And we all know that some of that's broken, but I have heard, and I don't know the specifics, like there are companies now that are like, you want us to install your agent, your thing, your software, give us your SBOM, like, and sign it and give it to us. Right.
Wow.
So, as you should, right? Like that's a good, before you install random stuff in your corporate IT infrastructure, you should understand what's going in there. And Kubernetes itself as a project is also generating SBOMs for all the components and doing cosign stuff. So we're seeing better supply chain emphasis inside of Kubernetes proper, which is also good.
Right. And the next two I was going to combine, which is one was overly permissive RBAC configuration and the lack of centralized policy enforcement. I kind of like to combine those two. So what's the RBAC and policy enforcement there?
Yeah. So RBAC, the Kubernetes API does authentication, authorization, and mission control. Authorization is RBAC. It's combining roles, cluster roles, role bindings, and cluster role bindings for humans and service accounts to give you access to do things, whatever it may be. Now, RBAC is highly configurable, but it oftentimes is just like misunderstood. As an operator, you're like trying to combine these verbs with objects and like in subjects, and it ends up being, I'm going to give up and give you too much. That's the TLDR, and we need to not do that.
Yeah, like too long. Don't want to read this. Like, just what do you need? Admin, go on. Go on with your life.
It's no different in cloud, right? It's just, I just don't think we're doing much about it in Kubernetes yet. And then policy enforcement is, we already talked about that. It's admission control. It's saying, I will stop things that look like this from entering this cluster. That's actually taking the misconfigurations, doing something about them.
Right. And your inadequate logging monitoring is pretty straightforward. I guess it's not enough. Is there something from Kubernetes that enables people to do logging and monitoring, or is that something they have to look for another, like a Caverno is a project for like a policy management, but is there similar for logging and monitoring as well, or does Kubernetes by itself has a lot to offer there?
Yeah, the Kubernetes API offers what is called Kubernetes API audit logging.
Yeah,
it's enabled not by default necessarily. All the major if you're using managed Kubernetes, it's kind of a button you click to turn on. Now it's very valuable, and we do very little with it as a whole in security. We kind of just place it into some backend system and hope for the best, and we can do better. Like there's very interesting logs and events happening at any moment. And otherwise, like your applications typically standard error, standard out, right? Like the apps themselves, there's Prometheus metric exporters and things like that. If you want, actual metrics, there's tons of stuff. Like no shortage of logs. It's just like we should do something with them.
Fair enough. The next one is also fairly obvious, but I think maybe people may not. The broken authentication one.
Yeah, I mean, access to the Kubernetes API, it's choose your own adventure. So you need to choose a path that isn't a hard-coded credential. You can have you need to be able to revoke access, which a client certificate doesn't allow you to do in Kubernetes. You need to not share credentials. You need to not use static tokens or service account tokens from the outside of the Kubernetes API. There's a lot that can go wrong there. And it's usually like use OIDC type things that you're already using that support MFA, that also have an RBAC policy that's appropriate, is the recommendation there.
Oh, sweet. And missing network segmentation control is the next one.
Sure.
Is this where service mesh comes in? Or no,
it can. Yeah. By default, Kubernetes is a flat network. So it doesn't matter what namespace you're in. Pod A can talk to pod B. And it's up to you to make something else happen, right? And it's typically not appropriate for every single workload to be able to have full network access to the next thing. So out of the box network policies, there's overlays, there's things like Flannel, Calico, there's Cilium, there's no shortage of like fancy plugins that you can use to then build different style policies on top of. Service mesh is one of those, as at layer 7.
And the secret management failure. I think you mentioned an example from Google Cloud earlier where we spoke about you can use the KMS pieces from the Google Cloud space. So what's the secret management failure?
Yeah, I think it makes the list because secrets are hard always. How do you get a secret from point A to point B? And how do you promote it across environments? How is it encrypted at rest? And Kubernetes doesn't make that easier because everything comes back to RBAC, right? It's like secrets in Kubernetes, if you choose to use them, are base64 encoded, key value pairs that sit inside of etcd. They're accessible through the Kubernetes API. If your RBAC's broken and everybody has access to list, get, describe secrets, then it doesn't matter. Like it's open. It's a blurry line. So you want to make sure that you've at least thought about secrets management. Maybe Kubernetes etcd style isn't the right place. Maybe you just use KMS and your application is responsible for it. That's something you just need to put some serious thought into.
Interesting. So that's my dog. So it shook the entire table. I don't know if you could see it, but it's like the entire table was shaking because of him. The next one is misconfigured cluster components. So this is obviously talking about multiple container or multiple clusters talking together.
Yeah, it can be. And you can kind of bundle 9 and 10 together. A cluster has things like the kubelet, things like the schedulers. There's lots of different sub configurations within those components that you as the operator might not even be aware of. You may not have control over all of them if you're in a managed environment. There's flags that you can pass the kubelet that make it susceptible to using anonymous requests and things of that nature. They're outlined in the CIS benchmark, but they are certainly something to be aware of. And same with vulnerable components. Like Kubernetes has vulnerabilities. There's CVEs that come out with different components. Istio has CVEs, Argo CD, like all this ecosystem is not like, the CNCF landscape is new and busy and crowded and very complex, and vulnerabilities will exist with out of the box Kubernetes components, and you have to maintain that and keep track of it.
Yeah, and probably which kind of links really nicely to the last one as well, which is the outdated and vulnerable Kubernetes components as well.
Yeah, I mean, to that nature, like the Kubernetes API, if you run an old version, like there's a live feed of Kubernetes CVEs on Kubernetes.io, and you have to be aware that your cluster has a vulnerability, right? And it's complicated. There's just a lot of stuff running in there that could have issues. Even back in 3 years ago, there was I think it was a run C vulnerability that was the critical CVE. Every Kubernetes cluster is affected, and you basically had a path to escalating out of a container onto the node. And that's a thing, right? Like your run C and container D and these things that power Kubernetes are targets. So you got to track and remediate.
Yep. Oh, wow. And to your point then, I guess to what you were saying earlier and kind of zooming out a bit onto the whole top 10 that exists at the moment.
Mm-hmm.
There's network, IAM, vulnerable component supply chain. A lot of these, as best practice, coming back to the whole topic that we are here for, the combination of using something like a benchmark and I think like a top 10 or a cheat sheet, it's probably a good way for someone to kind of have that baseline to understand, oh, this is a great way to do Kubernetes. Maybe would this only apply for one cluster? How do people scale this to multiple clusters? Because most companies would have multiple clusters, right?
Yeah. So yeah, we work with companies that are, approaching 200, 250 clusters. And
250 clusters.
Yeah. And
wow.
There's the other end of the spectrum where you have 3 mega clusters. They each have 2,000 nodes. And each present different challenges, because the security boundary of multiple clusters is definitely strong, but then you're dealing with you could have 100 of the clusters could be running outdated Kubernetes, or you're due for an upgrade, or you don't have the right policies on some subset of those clusters. If you do a mega cluster, then your RBAC needs to be tight, which is, we all know, is hard. So applying this across multiple clusters is a challenge, right? And we at KSOC think about it one way. We definitely have the ability to carve things up, distribute policies to some subset of clusters. But if you're doing it yourself, you're going to need, number one, asset inventory. Like, where are they? If you have over 100, you're not going to just know. If you have 3, maybe they're kind of special pets. But if you have 100, it's just all over the place. So you need an asset inventory dashboard. You need policies, because there could be 20 of them that are in scope for whatever, PCI or something. They are different, and they have admission controllers and things that are very hardened. And then you have dev clusters that maybe you relax the requirements on. So multi-cluster it's tough, and I think we weren't ready for it. We probably weren't ready for Kubernetes in one cluster, yet alone 100. So it is going to be our next big challenge, I think, because now they're in all clouds, right? Like, you rarely, if you're in the 100 cluster club, you're probably in all 3, and you probably have some bare metal stuff sprinkled in there, right? So,
wow. Wait, so you're saying this is on managed Kubernetes as well? So from someone who's a provider, wow.
Yeah.
Damn. I don't even know if, because the providers themselves, like Amazon, Azure, Google Cloud, they don't really give anything for multi-cluster management kind of thing. For them, each one of them is an individual component.
Pretty much,
right?
Yeah, and they could be likely in many accounts, right? So
that's right. Like,
you could have 100. Yeah, you could have 100 accounts with 100 clusters, all with different IAM, all with different acts. I mean, it's
to your point, then maybe first step one for people who are listening to this is do an asset inventory and find out how many Kubernetes clusters are running across your organization to start quantification.
That's a great exercise for all security professionals to partake in.
Is
with
that easy
anything,
though?
right?
Is that easy to do though? Like, I think, are there tools for it?
It's well, we have a tool for it, but there aren't not many. Like a CSPM is going to try to do some of that, right? Like a cloud security posture management tool. The problem is that usually stops with like, I found an EKS cluster, here it is, but you don't really crack open what's inside of it. You just see it as its individual piece. You could probably have some scripts that do it constantly. You just daily run like an EKS get clusters command across all of your active accounts. But then there's like always the data science team is like, hey, well, we have 4 clusters over in GCP. And then you're like, cool, I didn't know about those for the last 2 years.
That definitely is. I mean, wait. So wait. I mean, where does this leave us then? I think because a lot of people are. So maybe the old analogy of how do you eat an elephant one bite at a time? Just do the asset inventory first and see how many clusters you find, and then you kind of match that with cheat sheets and CIS benchmarks and stuff.
I think our recommendation is always like, understand where your clusters are, get the full picture. Then you do, the asset inventory inside, right? You're looking for misconfigurations. Doesn't have to be the entire CIS, contrary to popular belief. Like the CIS benchmark is good, but it's full of, if you followed it step by step, you would spend the next 3 years trying to, have this checkbox. You want to pick the things you care about the most. And then ideally you want to squash categories of misconfigurations, not individual workloads, right? Like, because there's tens of thousands of these, you're not going to just pick them off one at a time. You're going, maybe, this quarter, like we have 400 privileged workloads across all of our clusters. Like, that's what we're going to tackle, and we're going to figure out how to get there, because we know that privilege is bad, and we can give an allow list of system calls or something of that nature, right? Like you don't want to just try to do everything on day one. And yeah, I don't think training hurts, right? Like letting developers understand what these things are before you get in a situation where you have to do a firefighting exercise, probably a good thing too.
Yeah, I'm talking about firefighting. So one question from Saeed here. I have a case where deploying IoT as a cluster for key management. Does it make sense to use KMS if using EKS?
Yeah, sure. Yeah, you'll have the one side of opinion is like, people screaming about vendor lock-in. Everyone's like, I need my freedom and I don't want AWS to control me and I don't want to use what they have to offer. KMS is that example, but also it's easy and secure and backed by an HSM, and it's like, why not, right? So you're deploying Internet of Things as a cluster. That's good. Yeah. We're talking to a set of meatpacking facilities that all run Kubernetes inside of each of the facilities. All their IoT devices report back to Kubernetes. It's kind of cool.
Wow. That's pretty cool.
Yeah. Man. KMS is great. You should use it unless you need to be truly portable. Then you could consider something like HashiCorp Vault running inside of the cluster, right? Or you could use Kubernetes secrets. Like it's a threat modeling exercise, right? At the end of the day.
And it's got a follow-up as well after that. Also, is it recommended to use a PKI for cluster if I already have a PKI server management cert for sender? Lots of confusion here. Public key infrastructure. So
yeah. I think Kubernetes is going to manage certs for you internally. I think there's too much nuance to that question to answer with any.
What's the general opinion on having cert management done in Kubernetes? Maybe we can have that as an answer.
Well, I mean, picking on like TLS certificates as an easy example. Typically, the pattern is to use something like the Cert Manager project, which is going to sit inside of the cluster, probably integrating with Let's Encrypt or something like that, and it's going to revoke and refresh and deal with cert rotation, things like that for TLS termination at like an ingress perspective from like, call it Nginx. That's a fairly established pattern. I don't think it is an external reliance though, right? You are not using baked in Kubernetes things. Cert managers, a third party component, sort of, kind of. So you're taking certs and trusting this thing, putting them into local storage typically, and terminating TLS. There's a CA, there's a certificate authority in the Kubernetes API. That's kind of a different story where you're minting client certificates for access to the cluster.
Mm-hmm.
I don't think you want to yank that out and do it elsewhere. I mean, but because there's too many internal complexities there. The kubelet needs the CA and things like that. So it's I would pick something, straying away from the pack when it comes to cert management, PKI stuff. It's usually a bad idea. So just use the defaults, use your cloud provider offerings, and use what Kubernetes has established.
Awesome. Great answer as well. Hopefully that answers your question, Syed. That's I think the final question that I had for the interview was just, where can people learn about securing Kubernetes, man? I think, is there any thoughts on where people can learn about Kubernetes and security within Kubernetes?
Yeah, you can come to KubeCon and come to one of our workshops. You can go to kubernetes.io. There's a lot of security content there, and like, it's a great reference. There's the top 10 has lots of links. The OWASP cheat sheet. You could follow me on Twitter at Jim Mesta. I post Kubernetes security stuff pretty much solely, and like maybe some mountain biking things, but there's more and more out there. And yeah, I think there's a certification, the CKS, right? The Certified Kubernetes, CKS, Certified Kubernetes Security. I guess that's it.
Just...
Yeah, you could take that. There's more than ever. 6 years ago, I was writing a lot of this stuff from scratch, and it's pretty amazing where we've come. There's Hacking Kubernetes by the folks at Control Plane, Andrew Martin.
Oh yeah,
and that's a great reference. There's no shortage of information.
KubeGoat as well.
There's KubeGoat. Yeah. That's Madhu's project.
There's so many now.
Yeah, we have a awesome Kubernetes security GitHub page. It's okay. I'll send it to you. It has a bunch of links.
Oh yeah, sweet. Yeah, I'll probably add in the show notes as well. So just mindful of I'll probably share the link with the show notes. But where can people find you, man? I think I've been taking way too much of your time as well, but I really appreciate all the time you're spending with us. So where can people find you on the internet? They have more Kubernetes best practice security questions.
Yeah, just Jim Mesta on Twitter. You can hit me up on LinkedIn too. I saw you and Shipley had some post today that has like 900 million reactions. I got like 45 LinkedIn requests today from that post. LinkedIn's pretty good. If you could cut through the noise in my DMs there, or Twitter is fine. Yeah. Or Jimmy, Jimmy at ksoc.com. Yeah, hit me up anytime.
Awesome. I'll leave those links in the show notes as well. But dude, thanks so much for coming on and sharing all this as well. And thank you for giving light to the top 10 project as well for Kubernetes. At least now people know to go to as well.
Please contribute. It's getting translated into different languages. We have like 10 active contributors, so I'm excited. Come on by and we'll make it better over time.
Awesome. All right. Thanks everyone. Thanks Vineet. Thanks Rama. I'm gonna quickly Bilay, Ameya, Syed, and Ankit. Thank you for all the comments and questions as well. And I'll see everyone else who was online as well for next episode on next weekend for Kubernetes again. But yeah, thanks so much for Jimmy. And thanks everyone.
Man.
Talk to you soon.
Bye all.
Thanks, everyone.